Okay. Hi, everyone. Welcome back. So we are in the last part now of um, our EDA lesson for today. So, okay, so this section is going to be the coding section. So please open up, if you have not already, open up your coding notebook for this, the Intro to EDA Coding. You are going to be doing some of the exercises. So, try to follow along in your notebook as well. So, okay. Let me check in. Hopefully everyone has this open. Yeah, if you have some kind of technical questions, you can put those in extra help to run all of this in your terminal. You should have a requirements.txt file that will install all of this. So we'll start with the introduction while people are getting their notebooks open and getting started. So this will be hopefully familiar, what you've done in previous cases. So the first thing that we do with our data set, so this is the coding portion of that Airbnb data that we looked at before the break. So we need to load in our CSV, which we are going to name, it's named listings. That's how we're defining our variable or defining this data set. It's the CSV. And then we want to use listings.shape, and that tells us how many rows and how many columns we have. So we know from looking at our previous analysis that we had about 30,000 rows, which is confirmed here, and about 81 columns. So we can go ahead and look at those columns and see the way that our data is organized here. So we can use this pd.options.display max column is 100. This will show us all of our columns since we have 81, and then we can do this listings.head 3, which will give us the first 3 rows. So we can scroll through here and we can see that we had discussed parking, and that's in here somewhere. We can see that it was a 1 and a -1. So these are things that you should look through in your data to scroll through more than 3 rows, but to find out how your data is organized. We have a couple of these variables that are a 1 or a -1, indicating yes or no, like air conditioning is a yes or no. Check-in 24 hours is a yes or no. So just looking at the organization of your data will be important. So it's good to look at your columns and how things are organized. Okay, so that's just our introduction to loading our data set and looking at it. So the first thing that we had wanted to do, I will go through the examples and then you will try the exercises on your own, and then we'll go through the answers. So we're going to use the describe command to compute some of those important summary statistics for the above variables. So what we do here is our listings variable that has our data set. That's basically going to be the name of our data set going forward. And we are pulling out these particular columns of interest: price, bedrooms, bathrooms, number of reviews, and we're using this .describe function. This is super helpful because this .describe function will give us all of that summary information that we needed for our previous analysis to look at the mean, the minimum, maximum, and these quantiles. So this is also, that good place where you can stop and look for any outliers, things that don't make sense, looking at those minimum and maximum values, things like that. So this is the code. We just call the columns that we're interested in from our listings data set, and we use this dot describe. We can also do this and we can define the particular quantiles that we're interested in. So, here it automatically gives us the 25th percentile, 50th, and 75th. But we also wanted to know before the 90th, 95th, and 99th. So we can do this in a similar way. We call the columns that we're interested in from our listings data set, and we use dot quantile, and we can define them. And then this tells us we analyzed some of this data in our previous case to notice things like there's a huge jump in price between that 90th and 99th percentile, those distributions, that 90% of our data was at this price point or lower. So that is a great way to define some of those quantiles that are, that we would be interested in. Okay, let's see some questions. So the 0.9 quantile means that 90% of your data is at or below this price. So 90% of our data is at $250 or less per night. So, and yeah, analyzing the 99th. So the reason that that is important, these are great questions. The reason that this is important is it just tells us, when we get the minimum and the maximum, that really doesn't tell us a whole lot about where our data falls. We did get the 75th percentile, but this maximum, we don't really know the distribution, but knowing that actually 90% of our data is at 250 or below is pretty helpful. And knowing that, I guess that really this is like the top, this 450 is really the top. So I guess, you could say that it's not super important to know the 99th, that 90th maybe tells you, but seeing this big jump that's really that 10% of your data that's between those values is pretty interesting to see. So how are we doing following along? Okay, some people are loading their packages. That is fine. And you should have this code, I think, already filled in your case. So hopefully once you get everything loaded, you can run some of these and see the output. But anyway, that's how you would define particular quantiles you're interested in. So let's try exercise 1 on your own. So let's go ahead and try in your notebooks to plot the histogram of the above variables. So for this one, let's see, so we have about 40 minutes. So we'll take a couple of minutes here. We'll see how long these exercises, I'll try to gauge how long it takes everyone. But let's try taking a couple of minutes to plot the histogram of the above variables. And maybe we could add in polls and answers. If it's possible, just a poll that everyone can like when they are finished making their histogram. If that's possible, just like a yes, you're finished, or no for exercise 1. And I will, while you're doing that, I will also check the live chat here and see if anyone has questions. So yeah, the question about those, I think, values for the quantiles. So yeah, these can be defined however you want. In this case, we were looking kind of at that top because we see our maximum is 500 and 75% of our data is at 175. The reason we chose these higher quantiles is because we're kind of interested in seeing that distribution. That's a pretty big jump between that maximum and that 75th percentile. So, you can pick any values you want, but these were the values that we chose in order to kind of analyze in more detail that distribution of price. And then a good question about the price equals 0 for the minimum. Yeah, so that could be outliers for sure. Because it's unlikely. I mean, the thing is, you would have to look into that. It could be that on Airbnb, there are legitimate listings that have $0 that are for free. So you would they can be in this case considered an outlier, but before you would cut them out of your data set, you should go through and verify some of them, pull out all of the listings that have 0 for the price, and maybe look at what that data looks like to determine if it's real. But I agree, it does seem unlikely that there are a lot of free listings. Okay. So we are going ahead and making these histograms for the variables for price, bedrooms, bathrooms, similar to what we saw in our previous case. We saw those histograms already. And okay, yes, thank you for creating the polls and answers. If you can go to polls and answers, and if you can like or react, just so I can gauge how many of you have finished this portion. Okay, thank you. Yes, thank you so much for all of you responding to this. The numbers are definitely increasing very quickly. Okay, so yeah, quite a few people have finished, and it's okay if you don't get every single one of the variables plotted in this time. I just want to give you a chance to try one because the pattern will be the same for all of them. And yeah, I see some people sharing their output. So let's go through some of these. So like I said, if you get one of them, it's okay if you didn't finish all of them because it's basically the same code. So to start with price, to make the histograms, it's a pretty simple code. It's just listings, which is our data set, the column price dot plot dot hist, and then you can add a title, and you should always add titles to your visualization so you can figure out what you were graphing. But yeah, this is price. So pretty straightforward. You just it's this dot hist function, super helpful to make histograms. The same for bedrooms. It's you call your data set, the column you're interested in, dot plot dot hist, and then bedrooms as the title. And again, the same code for bathrooms. So if you get one of them figured out, you should be able to get all of them. And these are the same histograms that we had talked about already in our analysis of EDA. So I won't spend too much time going over that again, but just let me know if you have questions about this, but hopefully this makes sense. Pretty straightforward code. Okay, so the next thing that we had wanted to do was to make box plots. So we had wanted to compare in our previous case, we looked at the comparison between price and bedrooms, and we made some box plots for them. So the way that we do this is also, hopefully will make sense when you see this code, that this uses the Seaborn package. And I think you've used this in the past, but Seaborn is just a visualization package that creates really nice kind of professional looking visualization. So they have the box plot function built in. So it's sns.boxplot. And then to compare these two variables, we can define our x-axis and our y-axis, and we put them in quotations to tell it that we want those columns from data equals listing. So we have to give it our data source to look for. Where should it find its X and Y from listings? And then we give it a title, which could be whatever you want. In this case, box plot of price versus bedrooms. So again, pretty straightforward, just sns.boxplot, and then tell it what you want the y-axis to be, the x-axis to be, and where to find the data. So for exercise 2, you are going to create box plots of price versus bathrooms, price versus number of reviews, and price versus review scores cleanliness. So again, I'll give you some time now to work on this. Like with the previous exercise, I would say you don't necessarily have to have all of them finished in the time because it will be very similar code to make each one of these comparisons. So I'll give you a chance to work on these. And then again, if we can have another message on just reacting to the message in polls and answers when you have finished exercise number 2. And I will also at the same time answer some questions in the live chat. Yeah, all of your plots look good. And a good point in the live chat that there are different ways to make these, and you'll see, as you're going through basically everything in Python, visualizations, analysis, there are multiple ways to do it. So if you have code that is slightly different from the answer, but you're getting the same output, that's completely fine. It's fine to have different code for a visualization or for an analysis. And yes, you can create a subplot to see all of them. You could have also done a for loop and created, for as many different columns. You can create histograms for the whole thing. There are multiple ways that you can visualize. So great comments in the live chat. Oh yes, and someone asked if we could look at the answer really quick. So this was, and I think answers will also be posted in the polls and answers, but this is the layout for making exercise 1. It's this listings, and then the column you want .plot.hist. Okay, and I see lots of posts of your answers, of your plots, looking great. And yes, it looks like the answers in polls and answers, awesome. Okay, and a lot of you are done with exercise 2. Okay, so let's look at exercise 2. So again, this will be very similar code to what you, to generate all of these plots. So for this one, to make the box plots, it is the same as our example. So sns.boxplot, x equals bathrooms, y equals price. Where do we, excuse me, where do we get it from? Listings. And then we have we can add our title. So this is, hopefully makes sense. It is this, the same as what we show for the example for the code, but logically when you're thinking about, writing that out, hopefully that makes sense for making these visualizations in terms of pretty straightforward, just define the visualization you want. What do you want your X and Y, and where to get the data from? So this is how you make those plots that we talked about previously, using this box plot. So now what we want to do is look at our correlations. So let me scroll down to make sure. Okay, so this is how we, so the next thing that we did is, so the next thing that we did was create these correlation matrices for price versus all of our columns. So the first thing that we can do is if we wanted to know the correlation for price and bedrooms, also this is just one line of code to find this correlation. So we would do listings, which is our, we always have to call our data set, and then the columns from our data set, and then .corr, C-O-R-R. And then that will give us this correlation matrix, so we can see that the correlation between price and bedrooms is 0.45. And then if we wanted to know, and we went through, these are the same R values that we talked about in our previous case, where we went through all those numbers. We explained what does positive and negative correlation mean. So this is just how you make those numbers, how you get those calculations. So if you wanted to make it for everything, you would do listings dot corr, and we can define this as core M. That's just the name we're going to give it, and then we can define that variable as listings.corr. So that is, this variable contains the correlation matrix for all of the columns. So this will compare all 81 versus all 81. Okay, so for exercise 3, write code to print the columns which are positively correlated with price. So we just want the columns that are positively correlated with price, from most positive to least positive, and then print the columns which are negatively correlated, from most negative to least negative. Okay, so that's our exercise 3. So a couple minutes here to work on exercise 3 based off of what you know for getting price and bedrooms and generating all of the listings. Now we want to, from our previous case, we wanted to figure out which things are most positively correlated with price and negatively correlated. Okay. Okay, see a lot of people putting their output for exercise 3. This one is a little bit trickier than our last exercises. Our last exercises were kind of copy paste. This one is a little bit more difficult, so we'll give a little bit extra time here. And don't worry if you aren't sure how to do this. We will go through the answer. This is just a chance to give it a shot on your own if you think you might know how to do this. And I see a lot of different ways in the live chat, a lot of different things people are trying, which is great. And if you're getting the correct output, like I said before, it is totally fine to have a different code from someone else. Okay, so let's take a look at the answer for the sake of time here. So one way that we can do this for exercise 3 is that we can pull our, if you remember, we defined this as core M, which is listings.core, our total table. So we can define this as positive pos correlation. So pos core, we just name our variable and we pull it from this previous one that had the listings of the whole correlation matrix. And we just want price from that. And we only want the prices or the correlation numbers that are greater than 0, right? Because we wanted the positively correlated with price. And then we can sort values ascending equals false, which means in descending order. And then we add this to frame, which makes it a data frame. So to frame just converts it to a data frame. So we just take this matrix that we defined earlier up here with this code, core M, we pull the price column for it, and we only want the values that are greater than 0. And then from there, we take this, our price column with this parameter, that positive correlation, that's all of these that are positive above greater than 0. And we use sort values, ascending equals false for descending order, and convert it to a data frame. And then this is our output. So we see all of our positive correlations here with price. And then we can do the same thing for the negative correlations. So we can define this as negative correlation, and we can say this core M, which was our total correlation matrix, price less than 0 for negative correlation. And then we can sort values again and convert it to a data frame. Okay. So And the answer again will be posted if you wanted to copy paste this code, or if anything doesn't make sense, let me know. Okay, so the next thing that we saw in our previous case was we saw that really cool heat map for New York that was overlaid on top of an actual map for New York. So let's talk about how we can make this. So you loaded in a Folium package. So Folium maps are a really great resource to visualize geographic trends. So we'll break this down. So we will create our Folium map. We name it Folium map equals folium.map, and then we can print that variable. And this uses the Folium package to make this map. And then this is just a global map. Okay, when we just have folium.map, it's just the whole world. So we were interested in New York. So let's talk about how we could define it to focus our map in. So we can define New York, or NY coords for New York coordinates, equals the latitude and longitude of New York. So you would have to look this up for whatever place you're interested in. So here we know New York's coordinates, and we would enter them in and then modify our previous code, Folium map equals folium.map. And for location, we would give it this, NY coords, already defined up here. So all we're adding here is just to specify we want it to be in New York. Okay, next, we want to add, you can add some cool features, just some more specific features here. We can also add this zoom start in our location. So this is the same code, just adding zoom start equals 13. So the difference here is you can see that this is kind of zoomed out for all of New York. But when we add that zoom start, we're much more zoomed in to our map. So that's just adding zoom start equals 13. So this should be filled in for you. So hopefully you can follow along in your notebook as well. Another thing that is just kind of a stylistic feature is a tile. So that's kind of the style of map, the style that you like. So one thing you can add to your code is tiles equals. The default is OpenStreetMap, which looks like this, and this color coordination, or the components here. So it's just a style of map. So you can change the tile, you can change the zoom start, just for whatever you think looks best. So all we've done here is we still have New York. We've just zoomed in a bit, added our tile. And then, so for this one, for exercise 4, we're not gonna take a lot of time to do this, because we'll just explain. There are other tiles. So on your own, you can go ahead and copy paste, stam in toner. And what you would do is just change your code up here. So it says tiles equals, and put that name in instead. And you can play around with whatever you think looks best for the map. So, since we are a little bit short on time, so I'm not going to go through that, but you can change the style of your map. Okay, so one thing that we want to do then to create our heat map, to understand price distribution with location. So do you remember we made a heat map before that was overlaid on top of our New York map that was related to price? So the way that we would do that is, so what we're going to do is create an initial map like we did with our other Folium map. We're going to call this Folium H map, Folium heat map, and it's the exact same code that we have up here. It's this exact thing. So now what we want to do is, in order to make that heat map, we need to make a new layer. So we need to get, our heat map was based off of price. So we need to make a list that has our location, our latitude and longitude for each rental with its corresponding price for the rental. So the way that we do that is we make a list, and we need to zip, we use this function zip to match these different variables to each other, to each of their corresponding elements, sort of like this. If you have A with A, it will zip it together and make it into a list. Well, we need to make it into a list. But in order to do this, we need to, because we only want to pull from our data set latitude, longitude, and corresponding price. So to pull those things, we say zip, listings, the latitude column, the corresponding longitude column, and the price column. So that will take everything, the same latitude, longitude, and price, all from that row of your data set, and put them together. And then we want to make it a list. So we say list my zip, which is here. So we're going to make a list. And then we can print out the first 15 to see what it looks like. So this is what our list looks like. It has all of the latitude, longitudes, and price. So, now that we have this list, we can add it as a heat map. So is everyone following? I know I'm going a little bit fast. I just want to make sure that we're able to talk through some of this. Okay, so we are going ahead now, and we need to add that heat map to our original map. So we have what we're going to call our heat map layer, and we're going to say it's a heat map, and we have already made list of my zip up here. We already zipped together our coordinates. So for that heat map, we're using list of my zip, and then these are stylistic components. So we have an opacity, a radius, and blur. So you can also adjust these in your own notebook and see how it changes. And you can decide what you like the best, but these are just for style, for the color and things like that. And then to add that heat map on top of our folium map, if you remember, we already defined folium H map up above. That was our just basic map of New York with nothing on top of it, just our map of New York. And then we can just say add child, that's the command, HM layer, which is this. So this just says add our heat map layer to our map, and our output looks like this. So we've created our list of the coordinates, and then we've added it onto our original map. So the steps to do this are to make your blank map with nothing, then make your list, and then add it on top of your map. And then you can save it as an HTML so that you can share it with people who don't have Jupyter. You can save it as an HTML that someone could just open. Okay, so for this, I'm going to give a quick minute to go through exercise 5. So we'll make a heat map using folium like the one we just made. So this one was based off of price. If you remember, here we did listings price. So if for exercise 5, you can make it with review score rating rather than price. So hint, very similar code to what we just saw in the example, but instead of price, you want to make the map on the review score, on basically ratings instead of price. And I will scroll up if anyone wanted to look at any of this code again. There's some good questions in the chat. You don't have to import extra packages if for a different city. You just need to know the latitude and longitude. In this case, we only have data for New York, so we put in the coordinates, latitude, longitude. If you had data for California, for your city of interest, you could put the coordinates in instead for your map and have that place. It's all within the Folium map package. Okay. So let's keep moving because I think we have about 10 minutes and I feel like we're going to go a little bit over. So this code, I will, just briefly go over that. It's the same, we create our same map, that Folium H map, the exact same code. The only difference now is that this is combined into one step instead of two for the zipping together latitude, longitude, and instead review, score, rating instead of price. So you can use the exact same code as before, just replace this review, score, rating. There's one other piece I didn't scroll down far enough. Sorry about that. So we will talk about this. One thing that was important here that we added in this exercise is the drop NA. So we dropped any missing values from our data set. And I'll take a second to talk. This is important. So we had this listings no nans, and we created this new variable to have our listings.drop NA because we don't want to modify our original data set. Okay, we just want to create a new variable that has this data set without the NA or the NaN values in it. If we had just done listings.drop NA, that will modify our listings data set from now on. So anytime we call listings in the future, it would have that dropped NA values, and we don't necessarily want that for everything. So it's important to create that new variable here that has the listings, the same listings data set, but without those NA values or missing values. From there, we pull out the review, score, rating, and it's the same code to make our heat map based off of the highest reviews. Okay. Okay. So example 2. So for this one, okay, so we want to plot the first 1,000 locations on the map. We talked about parking before, right? And looking at parking in the neighborhoods. So in this case, we're going to look at the first 1,000 locations where parking is not available or where it is available. So this code is a little bit more complicated. We're going to make a map that shows where there's parking and where there's no parking. So the way that we would do this is we already know that parking in our data set is listed as a 1 or a -1. So we have, we'll name our variable, lat long parking yes. So from our listings data set, we're going to pull out everything that has parking equals 1, which is yes parking. And for that, we want to take the latitude and longitude for everything that has a 1 for parking. We want the corresponding latitude and longitude. And the same thing for no parking. When parking equals a -1, we use the .lock function to pull out the latitude and longitude for everything where the parking column is a -1 or no. We make our Folium map the same map we've been using for New York because we want to add these things to our map. So then we're going to use for loops now because we want to plot 1,000 locations where there is parking and 1,000 locations where there's not parking. So the way that we do this is our for loop. So basically saying for each thing in the first 1,000 data points, we want to use folium.circle markers. So that's incorporated in the Folium package. It will add these circle markers. We need to tell it the location of the, to put the marker. So we're going to say the location, we have to give it our latitude. And then, let me scroll. Yeah, so from our lat log parking yes, which was up here, we defined that already. We already pulled out the latitude and longitude. We want to pull out just the latitude from that. And then because the way that the location works for this, when you add circle marker, just the syntax is that you have to define location equals and then give it a latitude and a longitude. So our latitude comes from this data set up here with parking yes. And then we have the longitude from the same data set. And then we can define the color, the rate, like the size of the dot, and the color, and then we want it to be filled in. And then the same thing down here for the no parking. We just use this variable instead to define the latitude and then the longitude. And then we say the color is red. And then for each one, we do this, we have to say marker dot add to folium map. So that will say, that will cycle through each data point from our lat long parking, yes, the first 1,000 points. It will take the latitude and the longitude, and it will add that little marker onto our map. I know that's kind of a lot. And the iLock part is because that is it's just specifically for variable or for numbers. So when we say this dot iLock I, so this is saying what was the latitude for point number 1. The I part is like for I in 1,000 would be like 1, 2, 3, 4, 5. It's going to cycle all the way through your first 1,000 points. So this is basically saying like point number 1. Take the latitude from point number 1, take the longitude from point number 1, and fill it in blue. Okay. Okay, so interaction effects. So we had talked about parking before and how price and parking had that weird no relationship, and we wanted to break it down by neighborhood. So this code is pretty simple. I know that we went really fast through the folium maps. I apologize for that. I think there should be answers, and hopefully you can play with this a bit on your own, have a chance to talk with your TAs if you are confused. But I want to say the best way that you can understand, the code is really to look at it, the answers that will be given to you, to run it, break down each line and see just run each line one at a time and see what the output looks like. And that can be a way to explain as well. Okay, so for interaction effects, we wanted to break down our correlation matrix by price and parking for each neighborhood. So the way that we do this is one line, pretty simple here. We take our listings data set, we say group by neighborhood, and then we do the correlation matrix of price and parking for each neighborhood. So adding this group by neighborhood gives us this output that says for each neighborhood, tell us what the correlation is for price and parking. So you'll see the output here looks like this, where we have price and parking. So we can see that for each neighborhood, we have this correlation number that's broken down. So for each neighborhood here, we can see that there's, we talked about those positive correlations. The next thing that we can do is filter out some of that redundant information. I think I was playing around with this earlier and I didn't change it, but this is the code that you have. So your output will look a little bit different than this because you won't have this variable column. I was doing what I told all of you to do, which was to run each line of code line by line. So this is the correct code. And I just hadn't run it all the way through. So I have this variable, but we have this code in here to drop it. Anyway, this is perfectly fine. But if we wanted to just have the number of parking price for each neighborhood, we can go ahead and drop parking. And then you have to rename the columns. That's why I was going through each line by line, because it actually gives you these 3 columns. You rename it, this one as variable, and then you should say that variable is the same as parking, and then we can drop the variable column, and then it should give us just a list of the neighborhood with the correlation. Okay, so we are actually out of time, and I will run just a second over. Yeah, so sorry about that. I know that's confusing. That I hadn't dropped this. So it will go ahead and run this on your own, and it will drop that variable column. So it should have, and that's on me. Okay, so for this, I'm going to go ahead and run through the rest, just because I don't want to cut into your plan rest of your day that's planned. And you can review some of this on your own. And I think you have a workshop with your TAs. So for exercise 6, we wanted to find out how many neighborhoods present a strongly negative, mildly negative, mildly positive, and strongly positive correlation between price and parking. So remember, we looked at this histogram and did this analysis previously. So we already have this CBN here. We already figured out for each neighborhood what's the correlation. So we can take this for CBN. We can take just the R parking price list, that column, and use plot.hist, and we can define our bins, because we're only interested in knowing what is very strongly positive, or kind of that weak positive, or weak negative, or strong negative. And so we just define our bins here. And so then that pulls our correlation matrix from up here and will tell us how many neighborhoods were in this range of 0 to 0.5, 0.5 to 1. Does that make sense? We are making these histograms based off of this bin that we have defined. If we didn't put this in, it will still make a histogram. It will just determine the bins for you. But in this case, we wanted to know specifically how many values fall in a particular range. Okay. So this is the same for looking at density plots. So I know I'm going very fast. I'm really sorry. I see in the live chat. Okay, so to make these density plots, we wanted to look at the parking for them in these different, for each neighborhood, whether they had parking or not, and the price. So the way that we do this to make those different plots for our 4 neighborhoods that we were interested in is, so what we're doing here is pulling out our 4 neighborhoods of interest, just defined in a list: St. George, Greenwood Heights, Rego Park, and Brooklyn Navy Yard. And then we say for nay, in nay to look. Okay, we're making our for loop. And if you are a bit unfamiliar with for loops, that is okay. We're just basically saying for each thing. This could have been I, J, whatever you want to name it. It's basically saying for each thing in nay to look. So basically all it's saying is for each one, for St. George, Greenwood Heights, Rego Park, Brooklyn Navy Yard. We first say data plot is listings, our listings data set. Listings neighborhood equals nay. So what that means is we're taking the column, the neighborhood column from our listings data set, and saying, does this equal one of these things, one of the neighborhoods in nay to look? So do any of the things in our neighborhood column from our data set match St. George, Greenwood Heights, any of these? So that's our first thing, is we have to say from our big data set with everything, pull out only those neighborhoods. And then we're going to use this Seaborn package again that makes these density plots. And so it's this KDE plot, data equals data plot here, X equals price, hue. So hue is like the color. In this case, it's like this orange and purple, or pink and purple. And so that is, we define the hue, the color, as for parking based off of whether there's parking or no parking. And we do want it to, shade equals true. And then we label, the label is parking. So that's up here, our label. So this is how we make our density plot. It's very similar to how you make our box plots that we did before. So it's just, you're defining the data it's coming from, your X and your, you only need your X because it's a density plot, which is price. We need to define our hue. So that's, what this is, what we're actually looking at here for parking and our label. And then since we did our for loop, this will make graphs for each neighborhood. Okay. So I think we are almost to the end. Hopefully won't be going too far, going too far over here. And I apologize for going very fast. I know that can make it difficult to learn. But I highly encourage you, to go back and look, ask your TAs questions. Also, it's recorded. So if you need to hop off for any reason, I think we're edging into your lunch break. So yeah, so I think exercise 8, I actually, let's see, I would like you to go ahead and maybe take a minute to try. If you need to drop off, I completely understand that. It's my fault for going over, but I want to give you a chance to try exercise 8, which is plotting the average property price across all locations as a time series. You would need to use a different data set. It's this data, it's scal.csv. So let's go ahead and try that to plot the average price across all locations as a time series. And while you're working on that, I will also say that these workbooks, if you haven't done this yet, what really helps when you're learning is to take this coding notebook and download it or use it completely blank. And after the lecture, don't look at the answers and try to go back and fill in everything on your own. After the fact, I think that's a really great way to try to learn. We've gone over some of the answers, but to go back on your own with a blank notebook and try to fill them in on your own is really good practice, just to get the feel for the syntax for these. So I hope, that will make sense. And let me check the live chat. Yeah, good points about color of plots. That could be a complete lecture on its own. So the color of plots makes a huge difference because, this is really hard to see. You also will have people that could be colorblind. People have difficulty seeing. So you do want to try to find really contrasting colors. So color scheme is a great point. Okay. And some good resources for the colors. So I guess I will also, while you're working on exercise 8, just scroll back up since we have this like quick minute, we can talk a little bit more about, just some of this code and these density plots, just to explain in a bit more detail. If anyone has questions, feel free to ask before we go over that next exercise. And so, making this for loop, I hope that this makes sense in terms of saying, we want to cycle through our neighborhoods. We want to choose which, we want to pull out from our original data set the neighborhoods we are most interested in, these 4, and we just want to make these density plots. And Seaborn is great for that, having it very user-friendly in terms of defining just where to pull the data from, what do we want to look at, what do you want the hue to be, which is, what do you want to actually plot here? Okay, so definitely worthwhile to look at that in a bit more detail later on. So let's look at exercise 8, which is, yes, we are there, everyone, our last exercise. Okay, so this was our last graph that we saw in our previous example or our previous case. So this was looking at data over time. So we had to load in a new data set here. So the same code, this pd.read CSV, and it was given in the hint here about using this new data set, this scal.csv. So we have that, and I would recommend just running, that, taking some time to make some new cells and look at that data set, see what the columns look like, what does the data look like, just like we did at the beginning of the case. We want to pull the date column, and I don't know if you've seen this yet in previous cases, but this toDateTime, super helpful function. All it does is say, it's telling Python in that date column that you have, it's just saying it's a date. Otherwise it could be confused for numbers, for a string, anything like that. So it's saying take that date column and tell Python it's a date. And you need to tell it the format the date is in, which is year, month, and day. So all this is doing is taking that column and telling Python, hey, these are not just random numbers, it's a date that is organized by year, month, and day. So then we want to group by date, and then we want to take the price column and we want to take the mean of it. Okay, so what this is doing, and then we want to plot it. So what this is doing is we want to group by our date, and we want to take for each one of those unique dates, we want to take the average price for that date. Okay, because we have, and that's how we're going to get this like kind of cyclical nature, because we want for every day, we want to know what the price was on that day, and we want to take the average price for each unique day. So that's why we add this group by first. We first want to group all of our data by date. And then for each date, we want to take the average price from our price column and plot it. Okay. Whew. Okay, that was very fast. We are 10 minutes over, and I'm sorry for that, but we covered a lot of information today. And so I would say that, like I said, the best way to learn from this is to go back after the lecture with a blank notebook and write in the code yourself. You'll have the answers to double check yourself, but make sure that you understand what each line of code is doing here. But these hopefully will be really helpful for you in your own EDA to make those folium maps, to make these histograms, density plots. You have the code here, and it's really just muscle memory in terms of seeing it a lot and then putting it in for your own data. So I will stop my sharing. Let me see here. And why can I not stop? I'm sharing. Oh, there we go. Okay. Hi, Monica. Sorry about that.
No, don't worry. Thank you so much, Sarah. I'm pretty sure all the fellows loved your presentation. It was so awesome. So guys, this is all for now. We are going to have lunch. Thank you very much again, Sarah. It was awesome. And now, guys, we invite you to have lunch and eat, because we know the lesson was a little bit, like a little bit much, and you are all tired. So go grab lunch, and we're going to see you back at 2 p.m. for the workshop portion. Remember that your TAs are going to share the Zoom links on their TA channel. So guys, thank you so much for being with us. Thanks again, Sarah, and we'll see you soon.
Bye.